Well, hello and welcome to another in the series of Enlit Europe interviews, in which we talk to leading energy industry professionals engaged in the structural change occurring within the energy industry. Through Enlit Europe's inclusive guide to the energy transition, we aim to share knowledge to foster connections and collaborations and promote the bold innovations in technology and ideas that are going to be needed for this vital and exciting evolution in our industry to take place. And I'm delighted to say that it's one such group of experts that I'm in conversation with today, all of whom are connected to the famous Italian industrial company Pietro Fiorentini. Founded in Bologna in 1940, the group made its name with world-leading technologies across the gas supply chain. But these days, it is developing technologies and solutions for a sustainable digital world. With me to discuss some of the ways Pietro Fiorentini is going about this are five of their experts. Leonardo Senatori is Renewable Global's leader for the company. Stefano Cerco is board member for NStack Hydrogen Solutions. Raymond Brotzak is founder of Micropyrus Bioenergy Tech. Matteo Gazzola is Green Gas Networks Development Team Coordinator. And Mauro Ferrari is board member of Fast Smart Gas Grid Solutions. Well, let's start by asking Leonardo Senatori to paint us a general picture. Leonardo, given that Pietro Fiorentini has been serving the changing needs of the energy engineering sector since 1940, what role is the company playing in the current energy revolution?
Thank you, Nigel. Well, let's say that in the last 80 years, Pietro Fiorentini has been always involved in providing access to clean energy. So, in fact, we are active in all natural gas value chain since our foundation. In the last decade, the renewable gases came into the picture, really providing a disruptive way of making gas completely sustainable, environmentally speaking. Besides the impact, environmental impact have in comparison to the fossil fuel, there are other key differences and challenges that green gases must face. The first one comes directly from European directives. In fact, we have to decarbonize the system, but at least cost. It means that the green gas value chains must also target economical sustainability. They must be competitive. On the other side, we cannot forget about the role that the energy infrastructure can play in this transition. And concerning the green gases, there is an increasing complexity coming for network operators that we must address. And in those two big areas comes the commitment and the engagement, our engagement to energy transition. Talking about the green gas value chains market segment, there are, let's say, three big needs that we are trying to contribute in solving them. The first one concerns the green molecules production. It means that valorize at max whatever is a byproduct or whatever is a waste. So here, basically, we are very active in the market of biogas upgrading, biomethane injection, bio-LNG, but we are also looking forward, targeting the new gases coming, like syngas and treatments of those new precious green molecules. Going to the right, we are providing solutions for the sector coupling business. So here is more related to the need of flexibility from the power business. We know that we cannot predict completely and control sun and wind. So we think that power to hydrogen and power to methane solutions can be a very useful tool for power producers. Concerning the carbon capturing, if we look at all energy outlook scenarios, we can see how the role of natural gas is fundamental even in the next decade. Not just switch it off and go to our renewables. but we have to find a way to make it sustainable. How? The answer rely in prevent any kind of fossil CO2 emissions before it is released into the atmosphere. Let's go now to the green gas networks area, where, as I say, we are helping solution network operators to have a new management of their infrastructure. Starting with the systems for gas grid acceptance, we have to deal with the fact that the grid was conceived with a top-down approach, so starting from big imports and distribution until the last mile. Now things are changing. We have many decentralized productions, so we have the need of making the grid more resilient. And the first point, it's just the top of the iceberg, but we have to change the paradigm of reversing flows across the infrastructure. The asset readiness, the point 5 that we can see in the slide concerning the asset readiness, we are redesigning and retrofitting our component plants installed across the infrastructure to make them tolerant to the new gases. First of all, hydrogen, that has different characteristics compared to traditional gases flowing into the pipes. Last but not least, solutions for the gas grid efficiency with a special focus to methane emissions. We have today solutions that could prevent methane to be released into the atmosphere through the transmission and distribution pipelines, which could be implemented as soon as today. Thank you.
Well, thanks, Leonardo. Now I want to turn the next question over to Stefano Cerco. Concerning new ways of producing renewable gases, Pietro Fiorentini is continually investing in technological startups to integrate differentiating processes in its plants, and I believe one of them concerns hydrogen production. Stefano, can you tell us something about that?
Yes, thank you. Thank you for your question. It gives us a chance to also better explain how the Pietro Fiorentini Group is trying to approach, in terms of strategy execution, the energy transition. As we said before, the market is evolving at a really fast pace, and the only way to become more competitive and to respond to market needs is to be as fast as the world that we are trying to play in. The startup incubation is an answer, and we are trying to leveraging this approach. And the idea is to create an entrepreneurial environment of excellence in order to feed our innovation engine, in order to create more competitive solution to respond at the market needs. One of these startups is Enstack. It is a clear example of this kind of commitment, and they represent the way in which Fiorentini is trying to be in the hydrogen market, in the hydrogen production market. Mm-hmm. This company was founded by Alberto Valli and Emanuele Castioni. They are still operating as CEOs in the company, and together with Fiorentini, that now is the major shareholder at the moment, we are trying to develop a sustainable business with different solutions in water electrolyzer. At the moment, we are using a technology, an anionic exchange membrane technology, that represent a really competitive alternative to PEM or alkaline solutions. There are more traditional solutions in electrolyzers. At the moment, this technology, even if it is less nature than the other technologies, it is able to leverage the growth of both technology, and could be more economically sustainable on the long term. At the moment, we are trying to work on the scaling up of the technology, since the sizes that we cover at the moment are not that big as the other technologies on the market. But the idea is to reach sizes up to 1 megawatt and maybe more as soon as possible. Of course, the advantages of this technology, and that's the reason why we choose this one, are many, and specifically, for example, the low capex, or for example, again, the use of demi water and not other kind of more expensive water, and of course also the load flexibility for appliances that can go for power to gas, since we are able to provide a solution that is loaded from 0 to 100%. At the moment, we provide a small-scale solution of 10 kilowatts of a single stack that we can apply in a modular way in order to reach sizes like 100 or maybe more kilowatts of size of the electrolyzer. As you can imagine, the final application are multiples, and starting from the mobility sector. So the idea is to promote the hydrogen refueling station in order to feed cars, trucks, buses, but also forklifts or trains. And in this way, try to overcome the limits of electrical batteries and also the limits of the electrical supply chain for electrical cars and mobility. Additionally, also the industrial segment is something that is really interesting for us, since the hydrogen can help with clean energy supply for industrial processes in order to reach a clean environment also for the industrial segment. And finally, the energy sector is another main segment in which we would like to focus, since hydrogen could be a solution for many off-grid energy production in small villages or more small solutions in which they need energy without having the access to the grid. But also a key segment is the power to gas in order to provide flexibility to the clean energy production as solar or wind.
Well, thanks. You've certainly alluded to the importance of power to gas there, and that was the subject of the sort of next question, because I understand it's not always possible to exploit locally the decentralized production of hydrogen. Professor Raymond Brotzak, can I ask you, what are the solutions to overcome this particular challenge?
Hello together, thanks for the question. Well, transferring locally produced hydrogen into methane is a solution to overcome the problematic of limited hydrogen integration into the natural gas grid. So power to gas with additional methanation, from our point of view, is an essential key technology. As renewable natural gas, or short RNG, the produced methane offers opportunities for an immediate reduction of greenhouse gas emissions. It is a key technology for the energy transition. That's because RNG can be handled in the existing energy grid infrastructure, meaning in the existing natural gas grid. RNG is a so-called hydrogen carrier, which is a long-term storable. And it could be even used in technologies which are state-of-the-art, like in CNG-driven cars, buses, and trucks, as already mentioned before. Future might be hydrogen, but state-of-the-art could be CNG-driven mobility. And even it is possible to use the methane, meaning the renewable natural gas, in gas turbines or CHP plants for heat and power production. Well, RNG allows the immediate further expansion of wind and photovoltaics, wind and power and PV plants all over the world, because they are fluctuating and we need some technology to store and to distribute that energy in the existing grids. So, well, it is a starting point for reducing the greenhouse gas emissions using RNG for sector coupling and for the needed energy transition in the field of mobility, heat production, and so we can even reduce the greenhouse gas emissions in this sector, which is the most challenge for the future, not only in the power production. So, while the power to gas with microbial methanation supports the new Green Deal of the European Union. And this is exactly what is the core competence of Micropyros Bioenertech. We are working in the field of the biotechnological process development using archaea. Well, I think not all of you know what archaea are. They are the oldest organism on our planet. They are more than 2.7 billion years old. So they are really very, very robust. They are self-reproducing, and they are very efficient and work under convenient process conditions. And that's the biggest advantage compared to catalytic methylation, because here we can work with convenient pressure and temperature conditions. And they are not very much affected by pollutants of the gases which have to be transferred into methane. So what we do is, in the field of power to gas, we take the carbon dioxide from different sources, add hydrogen from the electrolyzers, and transfer that into renewable natural gas. And this we do since 2012, when Micropyrus was founded. We started in a lab scale. After successful development, we did some tech scale development, and now we are in the industrial scale, where we are planning now 1 megawatt plants at different sites all over Europe. And since 2021, Pietro Fiorentini is the main shareholder of Micropyrus Bioenergy. So together we combine the expertise in the biotechnological processes for green gas production with the green gas networks knowledge of Pietro Fiorentini. So, well, at the end, I'd just like to add one point which is very important from our point of view. We are in the field of power to gas, transferring hydrogen into methane, into renewable natural gas, because we think this is needed to be able to act now, because we have all the infrastructure and all the technology to use renewable natural gas. It is just natural gas. But what we are doing is we even are able to transfer syngas from different resources like biological or organic waste material, which is produced via thermochemical conversion, into renewable natural gas. Even here, we are using archaea, which are able to transfer the carbon monoxide, the carbon dioxide, and even the hydrogen, which is in that syngas, into renewable natural gas. And that is, from our point of view, enabling us to use different sources for the renewable natural gas production. So the main competence of Micropyrus is using different sources, carbon containing, hydrogen containing, for the production of renewable natural gas. Adding hydrogen from the electrolyzers opens a wide field of RNG production. So let me wrap up. As a pioneer for biological power to gas technologies, Micropyrus Bioenergy creates flexible climate-saving solutions for affordable and clean energy. Micropyrus transforms renewable and originally often fluctuating energies into climate-friendly renewable natural gas that can be fed in directly into the natural gas, contributing to a sector coupling climate neutral economy. So these innovative technologies provide an immediate economic entry point for the storage and use of renewable energy, and for building a green gas economy using existing natural gas infrastructure. And so under the motto, Act Now, Micropyrus Bioenergy provides an essential contribution to the rapid and massive transformation or transition of energy systems for an effective climate protection.
Well, some exciting developments there in the field of renewable natural gas, and of course that's a great solution to many of the issues facing us. Of course, we're talking about this issue of injecting gas into the existing natural gas system, like hydrogen. But Matteo Cazzola, given Pietro Fiorentini's long experience in the gas industry, I mean, what are the main challenges and of course solutions to help us speed up this kind of hydrogen transition?
Yeah, thank you for the question. Pietro Fiorentini today overseeing the main challenges in the study of the compatibility with hydrogen
of the actual products that were designed and manufactured to be used with natural gas. We all know that hydrogen and natural gas has different properties. We can think about, for example, the density or the high heating value. And those needs a deep study of what is going to happen whenever hydrogen is going to be injected in the network. For example, if we think at density, what is concerning the tightness of the product along the gas grid need to be evaluated, as well for what is concerning the what is going to happen with the material, such as rubbers, for example, or carbon steel. So are they compatible with hydrogen or not? This is what Pietro Fiorentini has called the readiness journey. So understanding what is on the market, what is already in the field, if and how it will be ready for hydrogen. For Pietro Fiorentini, readiness means up to 100%. So we are not focusing on blending. We want to achieve the 100%. And for doing that, we are having a parallel approach in two ways. As you can see also from the slide, on the left side, we have the new solution hydrogen ready, and on the right side, the compatibility assessment for the installed asset. Starting from what is a new solution, so new design, new manufacturing process. Pietro Fiorentini is one of the key partners for the UK hydrogen transition. Today we are active in two projects, H21 and the I4IT. In the first one, we were capable to deliver last February a full pressure reduction station capable to use with 100% hydrogen, thanks to the knowledge that we built up, as you just said, in our 80 years of history. Thanks also to the recent past, or what I mean is the great challenge that we won for the smart metering, we were able to deliver a ultrasonic domestic meter for 100% hydrogen application in the domestic environment. So it's something completely new. It was a big challenge, but Pietro Fiorentini is today the main partner for such kind of application. What is concerning the assessment, so the compatibility of the actual asset that are on the grids, on this we are working in different ways. The first one is the test through laboratories. In this case, I mentioned the DMGL in the Netherlands, in which we were capable to test, so to real try our product, standard products, in a blending condition up to 30% of hydrogen, testing what is the safety, but also what is the accuracy of the meter. And this is our strategy. We want to test, we want to see what is going to happen in the real world with our products. And internally, as I mentioned before, density, so tightness of the regulators and meters. For doing that, internally, we are building our innovation center that will be fully dedicated testing hydrogen solution, actual solution, but also new solution that Pietro Fiorentini is now studying. And for doing that, we are working internally as a team to develop as soon as possible this laboratory that will give us new capability to test and to deliver to the customer safety and accurate products for the use in the field.
Well, thanks. Very reassuring to know the scale of testing and proof of concept that's going on within the company. Thanks, Matteo. Well, finally, turning to Mauro Ferrari, all the solutions we've just heard about, I imagine, are going to incorporate some aspect of digitalization. So how important is that, and how's that going to be achieved?
Yes, thanks for the question. This is actually pointing out the transition to digital, which is an essential part of the path. So we see a growing complexity. We have seen injection of renewable biomethane, biogas, sector coupling, which is addressing the power to methane and power to hydrogen, defining a single energy frame, which is actually asking for an increased resiliency of the network, together with increasing demand for security, for safety, and efficiency in terms of energy saving and reduction of the operational cost. So what we see here as an answer to all these needs and all these points that are defining the complexity of a new network grid, we have identified the smart gas grid as the answer, which is actually for Pietro Fiorentini the enabler of the future ecosystem. We see here we are pursuing a systemic approach to the implementation of this gas grid. First level is the large and wide distribution of devices that are enabling the data collection and monitoring in order to then enable local automation and optimization on a local point of view, and to go further in the pyramid of the implementation with data aggregation and deployment of what we call digital twins. So enabling the replication of the expected behavior of the network and feeding the models with the data collected from the fields. These are all, of course, features that are going to be supported and widely developed with techniques which are machine learning and artificial intelligence that are then enabling the last step that we see in the implementation, which is a full automation of the network with integration to smart energy, smart cities concept here. The strategy that Pietro Fiorentini is fully supporting at this regard is, of course, the investment in innovation, innovation in digital products. So making digital what has been traditionally pneumatic or mechanic, and of course we have already seen a couple of M&A activities, and FAST, of course, is one of them. The company was founded in the early 80s and is well known and established in the Italian market with field devices that are covering gas and water segment. But we would like to really point out the level of the increased level of efficiency that the implementation of application at the all software level, at the central software level, can provide to the network. Here we have just a few examples of them with the traditional real-time SCADA application that are providing what we call implementing what we call a decision support system, which is really able to drive decision for a more intelligent and smart gas grid. Thank you.
Great. Well, thanks for wrapping up with that kind of important aspect of it on the digital side. Well, gentlemen, do join us back on screen just for the final wrap up, because I want to thank you all for your valuable contributions, giving us some great insights into some real advances that are taking place, which have the possibility to create a truly sustainable energy and industrial sectors. And I think for me, one of the clear takeaways from this is that the energy transition goes beyond power and gas. It's the integration of other sectors that you've talked about, like automotive, like heavy industry, heating and cooling. All of this is going to be vital if net zero is to be achieved. And I guess with a proud legacy of achievements over the years, it's not surprising that Pietro Fiorentini are at the forefront of this kind of change.